Hello everybody, I'm Ayush Patel, and today I want to change things up and do a math video in which I will be talking about rationalization, an interesting process to turn an irrational denominator rational. Now, math and science are often called two faces of the same coin, and that's why I wanted to share this process because it makes it very easy to work with irrational numbers. After watching this video, you can tell me why you like rationalization. But before that, we need to review the types of numbers first. So there are 5 types of numbers: natural, whole, integers, rational, and irrational numbers. All of these are classified as real numbers. Now let's take a trip down memory lane and revisit some of these old friends of ours. Now you may have realized that I've kept irrational numbers separate from the other 4 numbers. That's because irrational numbers can't be denoted in a fractional form. More on them later. The first type of numbers we were ever introduced to were natural numbers, also known as counting numbers. They include 1, 2, 3, 4, 5, 6, etc., and are used in figuring out how much of a certain thing there is. The second type of numbers are whole numbers. They are natural numbers with the inclusion of 0. We sometimes take 0 granted in math. You see, 0 has 2 main functions, one being the value of nothing and the second being a placeholder. It was first found out by the Mesopotamians, Babylonians, and the Mayans at around the same time, who used it as a placeholder. Later on, Brahmagupta from India used it to denote the value of nothing. He showed that anything added or subtracted from 0 equaled itself. Brahmagupta's 0 made its way into Arabic math and algebra, which later came into Europe and spread across the Western world. The third type of numbers are integers, which include whole numbers and their negative counterparts. It should be also noted that 0 is neither positive nor negative. Integers are used in measuring altitude, how much higher or lower you are from sea level, and are also used in coordinates, calculating profit and loss, temperature, and etc. The fourth type of numbers are rational numbers. These numbers include integers but also decimals, which can be expressed in a fractional form. They are represented through discounts, interest rates, and many other financial activities. The fifth and last type of numbers which make up real numbers are irrational numbers. They can't be expressed in a fractional form but have many uses in our day-to-day life, like being used in calculation of things like speed and circle-related measurements. Let's come back to rationalization now. Now, as I mentioned before, rationalization is the process of converting irrational denominators rational. Let's take a look at this example here. 3 divided by root 3. First, you need to multiply the numerator and the denominator with root 3. After that, just simplify and you will get 3 root 3 divided by 3, which can be simplified to root 3. But what about something like this? Well, we can't just simply multiply root 3 because we won't be able to get rid of the irrational part, and that's what rationalization is all about. So here's where a conjugate comes in. A conjugate is an expression except with the irrational part multiplied with -1. Like here, a plus root b's conjugate is a minus root b. Now, you just need to multiply the conjugate with the numerator and the denominator, and you'll get something like this. Take a look at the denominator of the fraction we got. This directly ties into a formula, a plus b times a minus b, which equals to a squared minus b squared. If you don't believe me, here's the proof. So first, you use the distributive property, and you will get something like this. Simplify, and you'll get a squared minus ab plus ba minus b squared. After that, you will simplify, and you will eventually get a squared minus b squared. Now, we just need to implement the formula and the conjugate. So here, multiplying the conjugate, then we get this, and then you simplify, you get 3 squared minus root 3 squared, which is 9 minus 7, and then you'll get 2 as the denominator. Anyway, I'll let you off with these 3 problems so you can try them on your own. Thanks for watching. Bye!